The telescope will study how the earliest stars and galaxies were formed. On Christmas Day, NASA launched into space its biggest, most expensive and most powerful telescope yet. The James Webb Space Telescope will rocket into the cosmos and orbit nearly 1 million miles away from Earth. The telescope will spend 5 to 10 years studying the formation of the universe's earliest galaxies, how they compare to today's galaxies, how our solar system developed, and if there is life on other planets. ABC News explains how the telescope works, how it compares to its predecessor, the Hubble telescope, and what needs to happen for the mission to go just right. The history of the Webb telescope. The Webb telescope was jointly developed by NASA, the European Space Agency, and the Canadian Space Agency. Development first began in 1996, when it was known as the Next Generation Space Telescope, before it was renamed in September 2002 after James Webb, who was the head of NASA in the 1960s and helped launch the Apollo program that eventually went to the moon. The project suffered from numerous setbacks and delays, including a redesign into 2005, and ended up costing $10 billion. Construction was completed in 2016, and the Webb telescope underwent extensive testing before it was approved for launch. How does it work? The Webb telescope is an infrared telescope, meaning it uses infrared radiation to detect objects in space. It is able to observe celestial bodies, such as stars, nebulae, and planets, that are too cool or too faint to be observed in visible light, what is visible to the human eye. Infrared radiation is also able to pass through gas and dust, which appear opaque to the human eye, according to NASA. This is different from the Hubble telescope, which sees visible light, ultraviolet radiation, and near-infrared radiation. What are the goals of the Webb telescope? There are 4 goals of the Webb telescope. Firstly, scientists want to study the first stars and galaxies formed right after the Big Bang. Normally, humans wouldn't be able to see this because, as light travels through the universe, it gets stretched and becomes infrared, which is invisible to the naked eye. But an infrared telescope will be able to detect this light, which has been traveling toward Earth for more than 13 billion years, essentially allowing the Webb Big Bang to look back in time. This leads to the second part of the mission, comparing the galaxies from the past to those of today. Thirdly, because infrared radiation can pass through astronomical dust, which can't be viewed on a visible light telescope, such as Hubble, the Webb telescope will be able to study how stars and planetary systems, such as our solar system, formed, NASA explained. Lastly, the telescope will study planets outside of our solar system to see if there are any signs of life or if they have atmospheres capable of sustaining life. What is needed for the mission to be successful? According to a report conducted by an independent review board in 2018, there were 344 single-point failures, or steps that needed to work for the mission to succeed. The telescope was tucked inside the nose of an Ariane 5 rocket and launched from the European Space Agency's spaceport in French Guiana around 7:20 a.m. Eastern Time, according to the official countdown. It separated from the rocket after the launch and began unfolding. According to NASA, about 30 minutes after the launch, the solar panels unfolded so the telescope can get power from the sun. About 2 hours later, the antenna will deploy, so the telescope can communicate back to Earth. Three days later, the sun shield, which is 69.5 feet by 46.5 feet, about the size of a tennis court, will deploy. In order for the instruments aboard to work, they need to be kept at extremely cold temperatures, minus 370 degrees Fahrenheit or lower. The sun shield protects the telescope from the heat of the sun and keeps the instruments cold. Next, the mirrors will start unfolding and latching into place so they can reflect light. Overall, it will take 29 days for the telescope to reach the final stop on its journey and settle into orbit nearly 1 million miles from Earth. Thank you for watching this video. Don't forget to like, comment and subscribe.